Kia ora koutou, Reese from QuickSense here, and today we're looking at magnitude of a vector. Now what do we mean by magnitude? Well, we mean the distance from the origin. So looking at this vector here, 6 minus 8, let's just draw a little diagram. So 6 minus 8, the x value, we go across 6 and then down 8. So we're here. And the vector is this line here. So when it's asking what is the magnitude, well, what's the distance? How far away is it? Well, we can think of this as a triangle, where I go across and then I go down. And so there's our right angle triangle. So I know what this is, and I know what this is. The only thing I don't know is this. So what I'm going to do is show you the general equation. Right, the distance there is the square root of x squared plus y squared. This comes from Pythagoras' theorem. So let's look at this specific example. Right, 36 plus 64 is 100. So the magnitude of v is 10. In this question, we have a vector where the tail is not at the origin. Instead, the tail is at 3 minus 4. So once again, if I draw a very brief kind of illustration, the tail is down here. Its head is at point B, and point B is somewhere along the x-axis, so it's somewhere along here. Now, I don't know where it is, but I do know that it's going to have this coordinate. Right? The 0 comes from the fact that it is somewhere on the x-axis. So if the distance between 3 minus 4 and x0 is the square root of 20, well, what we're saying is that the difference, or if I were to take one and minus it from the other, I can find that distance there. So what does that look like? Right, I've got my x on the top, 0 on the bottom, and I'm finding the difference. That's equal to whatever x minus 3 is. 0 minus minus 4 is 4. Okay, well, what else is that equal to? It's also equal to the square root of 20. So what we're going to have here is the square root of 20 equal to, right, well, how do we write this as a vector? Well, remember, it's the x squared plus y squared. And so here we have our x value, and here we have our y value. So that becomes, I'm just going to do it over here for space's sake, x minus 3 plus 4 squared. So the first thing I want to do is square both sides. Okay, by squaring both sides, I can get rid of that square root of 20. So this becomes 20 equal to x minus 3 squared plus 4 squared is 16. Let's just get rid of that straight away. Now the thing I notice here is that I'm going to have some kind of quadratic, and I'm solving for x. So I want to set this to equal 0. So I'm minus 20 from both sides. 16 minus 20 is negative 4. I expand that double set of brackets, which is going to be x squared minus 6x plus 9 minus 4. X squared minus 6x plus 5. Now I'm looking for, right, this is still equal to 0. I'm going to factorize this using the null factor to determine what x is equal to. I'm finding, right, this is how I do this, I'm finding multiples of positive 5 that add to negative 6. And I know this is going to be negative 5 and negative 1, but you can run through all the different combinations here. So what does that mean? Well, that means that 0 is equal to x minus 5 and x minus 1, which means, therefore, x is equal to either 5 or 1. So what are the possible coordinates? Possible coordinates are 5, 0, or 1, 0, giving the magnitude the square root of 20.